The observable universe refers to the part of the cosmos that we are able to detect and study using telescopes and various scientific instruments. However, our observational capabilities are limited because light, our main source of information about distant objects, can only travel at a finite speed. As a result, we can only observe events and objects that are located within a certain distance from us. Anything beyond that lies outside our direct observational reach because the light from those objects hasn't had enough time to arrive. This is why we cannot directly see objects or events that occurred very early in the universe's history. The estimated diameter of the observable universe is approximately 93 billion light-years, which is far greater than the universe's estimated age of about 13.8 billion years. This apparent contradiction is explained by the fact that the universe has been expanding since the Big Bang. As it expands, objects that were once close together move farther apart, and the light from those distant objects takes longer to reach us. Therefore, although the universe is 13.8 billion years old, we can observe objects that are now much farther away due to this ongoing expansion. The observable universe is vast and full of mysteries, and there is still so much we don't yet understand about it. Despite these limitations, scientific advancements have enabled us to gain deeper insights into the universe's structure, composition, and history. Telescopes like NASA's James Webb Space Telescope, along with other powerful instruments, have played a crucial role in these discoveries. Recently, the James Webb Space Telescope made contact with a previously unseen structure in the far reaches of the observable universe. If you're interested in learning more about the latest findings and cosmic developments, you're encouraged to follow updates, like related content, and subscribe for ongoing discoveries. When considering what might exist beyond the observable universe, we enter the realm of theoretical physics and speculative science. Reaching those distant areas would require revolutionary transportation technologies that surpass our current understanding of space and time, concepts like warp drives or wormholes. These ideas, though fascinating, remain theoretical. Many scientists debate their feasibility, arguing that they may be fundamentally impossible or incompatible with the known laws of physics, such as the limit imposed by the speed of light. Even if faster-than-light travel were theoretically possible, it would demand technology far beyond our current capabilities. The theory of cosmic inflation suggests that the total size of the universe is at least 10^23 times larger than the part we can observe. This number is so enormous that it defies human comprehension. Since we cannot observe or measure what lies beyond the observable universe, we have no definitive knowledge of what exists there. Nonetheless, scientists develop theories based on information collected from distant galaxies. Agencies like NASA, in partnership with international space programs and research institutions, have made significant contributions to this understanding, even before the James Webb Telescope became operational. Before the deployment of the James Webb Space Telescope, NASA had already released astonishing images of the universe through the Hubble Space Telescope's ultra-deep field. Once operational, the James Webb Telescope began observing the most distant galaxy ever recorded. These observations revealed countless galaxies shining across the distant cosmos, appearing as they were just millions of years after the Big Bang, which occurred around 13.8 billion years ago. The expansion of the universe causes light to stretch into longer, redder wavelengths, a phenomenon known as redshift. This enables the James Webb Telescope to detect infrared light and study galaxies forming in the early stages of the universe. Through the observation of various galaxy fields, scientists have been able to examine how rapidly stars formed in the early universe. These studies have uncovered a substantial population of galaxies where stars were actively forming in those early cosmic periods. Such findings are both fascinating and thought-provoking. For a long time, humans have wondered whether we are alone in the universe. These recent discoveries suggest that there are likely millions of galaxies outside the observable universe, adding to the awe and mystery of the cosmos. The question of extraterrestrial life has never been more compelling. The discovery of planets beyond our solar system, known as exoplanets, has expanded our understanding of where life might exist. Techniques like the transit method and the radial velocity method have led to the identification of many such worlds. Some of these exoplanets exhibit Earth-like conditions, which opens the possibility that they could support life. One notable discovery made by the James Webb Space Telescope involves the exoplanet WASP 96b. Located outside our solar system, this planet's light spectrum revealed the presence of water molecules. Additionally, traces of haze and clouds were detected, features that were not previously expected on planets considered potentially habitable. Considering the discovery of habitable environments elsewhere in the universe and the rapid progress in identifying exoplanets, it becomes difficult to dismiss the possibility that alien life exists beyond Earth. While we don't yet have definitive proof, growing evidence suggests that the existence of extraterrestrial life is more than just a distant hope. It's a real scientific possibility. Another intriguing concept related to the vastness of the universe is the multiverse. The multiverse theory, also known as the many worlds interpretation, proposes that multiple universes or dimensions exist beyond our own. This idea stems from quantum physics, which explores the behavior of particles at atomic and subatomic levels. According to some interpretations, when a quantum system is observed, it collapses into a single state. In contrast, the many worlds interpretation suggests that the system instead splits into multiple realities, each representing a different outcome of the observation. Although this concept is still highly speculative and lacks conclusive evidence, it remains an intriguing subject in both physics and philosophy. Some scientists believe it may help explain complex phenomena, while others remain skeptical due to the absence of verifiable proof. As we cannot yet determine what exists outside our universe, the idea of a multiverse remains as valid and mysterious as Schrödinger's cat or the true nature of darkness. It is a concept that sparks curiosity and deep reflection, but still requires much more research to confirm. Another phenomenon that raises questions is dark flow, a term introduced in 2008 to explain why some galaxy clusters appear to be moving faster than expected based on the known distribution of matter in the universe. The dark flow hypothesis suggests that an unknown form of dark matter or dark energy could be influencing these galaxy clusters and pulling them in a specific direction. However, the scientific community has not reached a consensus on whether dark flow actually exists. While some studies support the idea and suggest a massive structure might be causing the motion, others have failed to replicate the findings or suggest that measurement errors may be responsible for the observed movements. As it stands, the existence of dark flow remains uncertain. We cannot say for sure whether it exists beyond the observable universe. More research and data are needed to better understand this perplexing phenomenon. What do you think? Feel free to share your thoughts in the comments. And if you'd like to stay informed about new discoveries and cosmic phenomena, remember to like this video, subscribe to the channel, and turn on notifications. See you in the next exploration of the universe.